Welcome to Functional Skills Maths. In today's video I'm going to go through a mock paper with you. Now, the purpose of today's video is to show you how you can maximise the amount of marks available for each question, both here in this mock paper but also when you come to your real test. What I've seen with a lot of the mock papers that have been returned to me is people are giving me some great answers to solutions to problems that can seem quite complex. But what I can't see a lot of the time is all the workings out they got to that answer. Now, each question you'll face both in the mock papers and in the real test will range from somewhere between 1 to 7 points. If we take it that 1 mark is allocated to the correct answer, you can see there's up to 6 marks available for all the workings out that get there. Now, there are times where you may give the wrong answer for each question, but if you've shown all the process to get there, you'll score points for that. So I think it's a real bonus that you do this. The way the video is going to work is I will bring up the question on screen, you will look at that, you'll pause the video, you'll attempt it, see what you can do. Once you've got as far as you can, press play, it'll cut back to me and then I'll go through the question itself. There may be points in the video where we've got a question and I might expand on it a little bit further to increase your knowledge that's linked to that topic. Okay then, let's get on with this and we'll come to question number 1. Okay, question 1. Calculate the median. So you see beneath the question there's a list of numbers put randomly there, as you can see on my whiteboard, that are written in black. This question is worth 2 marks. So if you remember what I said at the beginning, 1 mark is for the correct answer. So they want something else from you. And that first point is to put them all in numerical order, starting from the lowest through to the highest. Now, when we do this, there's always a tendency to rush these things, get a little bit lost, miss something. So just to double check things, the way I always approach this is I put all my numbers in the list, no problems there. Just to double check it all, I go through, right, where's my 10 in the main one, I tick those 2 off. And I run through each and every single number just to make sure that I've collected all of them. There's no gaps anywhere. So they've got 36, there's 1 over here. There's 2 more 36s, there's 1. And there is 2, a 45. There's a 48 somewhere, yeah, it's over on the beginning. There's the 50, and finally the 92. If I look along the top line, I've ticked them all off. And the ones I put in order, they're also ticked off. So just a little bit of a checkpoint there that I've got all the numbers and they're all there in numerical order. So how do we calculate the median? At this point, okay, I'm not going to physically do this because I want to use these numbers afterwards for something else. But what we do is we cross off 1 from the left, 1 from the right. And we continue from 1 from the left, 1 from the right, and we keep doing this all the way till we get to the centre and we find, well, in this example we've got 2 numbers left over. Now, ironically, they're both the same in value, so we're a bit easier with what we should do here. What we normally do is take both numbers, add them both together, find the average, i.e. divide them by 2. But because they're both the same, it's going to be 36. So the answer for this question, what is the median of these numbers? And the answer would be 36. All well and good. Linking on from the median, what also occurs is there's also another thing called the mode. So if we think about mode, what is mode? Mode is the most often. If we look at the list of numbers, you can use top or bottom, but I like to use the ones in numerical order here. If I was to find out what is the most common, it's the one that repeats itself the most. So if I look on this, and quite clearly again 36 stands out. So 36 is the mode in this sequence. If, however, there was no sequence, i.e. all numbers only repeated itself once, then the answer would be there is no mode. We look at then a third component is the mean. Now the mean is another word for the average. So what we do is we total all these numbers up. I know there's 12 numbers in total there. So once they've all been added together, divided by 12, and whatever the answer is there, that would be our mean. And the final piece of this jigsaw is what is the range. And the range is the lowest number subtracted from the highest. So 92 subtract 10 gives us 82. So the range of these sets of numbers is now 82. So now we've gone through not only the median and got our 2 marks, but we've gone through mode, median, mean and range. Hope that helps. Let's move on to question 2. Okay, moving on to question 2. Here we go. We find we're going to calculate what is 6.4 multiplied by 8.5. Again, there's 2 marks attributed to this question, so therefore we know 1 is the correct answer, therefore they want to see our workings out in this example. I've seen in the past, it seems to trip people up when you throw a decimal point into certain questions. And with that in mind, I've got my own approach to this. You might have your own separate ways of doing things, but as long as we get to the same answer in this example, we're good. So let me show you the way I would approach this. So I've got the 6.4 and the 8.5. Just to get rid of the decimal point, just to make things look a little bit easier, every number that is to the right of the decimal point, I'm going to make a note of it over here. So I know there's 2, so I'm going to make a note there's 2. And what I can do now is I can take the 6.4 and 8.5 and dismiss the decimal points for this time. So I'm going to take 64 and I'm going to multiply it by 85. Okay, and here we go. So we start off normal multiplication rules. 5 times 4 is 20, so that's the 0, carry the 2. 5 times 6 is 30, add the 2 I've dropped down, gives me 32. So, starting off, 64 times 5 is 320. Moving over to the 8, now the 8 is a 10. Okay, so it's representing 80. So before we start this, we'll always put a 0 at the bottom, and then we'll do exactly what we've just done with the 5. So 8 times the 4 is 32, so 2, drop the 3 down. 8 times 6 is 48, add the 3 is 51. So let's move the 3 just so we can see clearly. So we've got our 2 totals there. We add those together. You've noticed how I've kept things all nicely lined up there. Just makes it very easy and more visible about what we're trying to achieve. 0 and 0 is 0. The 2 2's gives me 4. 3 and 1 is 4, and there is the 5. So that is the total of 64 times 85. Coming back to what we said earlier about the 2, there were 2 numbers to the right of the decimal point. So what I'm going to do now is I'm going to put the decimal point back in, and I'm going to come in from the right side this time and put those decimal points in. So we've got 1, 2, the decimal point goes between the 2 4's. So the answer we've got now is 54.40. Okay, so 6.4 multiplied by 8.5 gives me 54.40. Now, we can also not include that final 0 because the value will still be the same. So that's fine. Okay, so hopefully that explains it all. Now, every time I do any maths question, I'll always get in my head roughly what's the answer going to be. And I'll take 6 times 8, which I know is 48. So I know the answer is going to be just around about 50. We know it's 54, but it's going to be around about 50. So I'm very confident that I've got the right answer there. Okay, hopefully that makes sense. Let's move on to the next question. Okay, moving into question 3. And in question 3, it's all about compound interest rates. We've got 3 marks available, so 1 for the correct answer and the others are for the workings out. Now, one of the common errors here is, even though we've got a starting point of £900 with a 6% interest over 2 years, one of the common errors people do is work out what is 6% of £900 and with their answer multiply by 2, and that would be their overall total. But that's not how compound interest rates work. Let me just show you. So in the first instance, in the first year, we will approach that. What is 6%? So we take our starting point, which is £900, and we've got to work out what 6% of that is. Now, what I'm going to do over here on my workings out, which will be on the paper itself, just to show how I've got to that point, but just for how I'm laying it all out so you can see it's different. Okay, I've got £900, and that is equal to 100%. If I find out what 10% of that is, so divide 900 by 10, I know 10% is £90. If we take the same approach once more, we divide that by 10 down to 1%. So if I divide 90 by 10, it gives me £9. So £9 is equivalent to 1%. If I want to get 6 loads of that, I'm just going to multiply it by 6. So I now know that 9 times 6 is 54. So if I got £900 at 6% in year 1, I'm going to earn 54 additional pounds. Make sure I put my pound sign there. Okay, so that's what happens after year 1. I've done nothing with my money in the bank. That's exactly what I've earned. To find out what we earn in the second year, we take the total, so £54 add on to our 900. So it gives us a grand total of a starting point. The beginning of year 2 is 954. So now we've got to calculate what 6% of 954 is. I'm going to take the same approach what we did earlier, but instead of looking at 900, it's 954. So we know that 100% is 954, 10% is now £95.40, and then move the decimal point back one place even further, £9.54. We again multiply that by 6. So what I now know is that 6 times £9.54 is £57.24. What I didn't take away, that's my total on there. So now I've earned in the second year an additional £57.24. I take that, add it on to my £954, and that there gives me £1,011.24 at the end of my second year within the bank. Now the question, if you read the bottom line of the question, doesn't say finish there. It asks you how much interest you made. So the interest is the difference between the end total of the second year subtracted from our original starting point, our £900 that we invested. So if we subtract £900 from this, that will give us £111.24. Yeah, let's get rid of that. It should be 00. Okay, so therefore the amount of interest we've earned is £111.24. Did you get that? Well done if you did. But hopefully I've explained a little bit more on what compound interest rates are now. Let's go to the next question. Okay, now on to question 4. The question was, how many boxes of leaflets can be stored in the cupboard? Now this question is worth a total of 4 marks. There's quite a bit of working out to be done here. So we take it step by step. Firstly, we're given the dimensions of the box. We're shown that the length is 14 centimetres, we've got the width is also 14 centimetres, and the height is at 25. The cupboard itself though, it just tells us what the base is. It tells us the base is 1.2 metres by 0.6, but it just gives us the height. So we now know that. Now, in this example, it doesn't really matter what the dimensions of the base are, because the base of our box are the same, so it'll equate, as you'll see soon, not a problem. But the biggest problem we can see there is we've got 2 sets of units. We've got centimetres and metres. Now when we do any question that has 2 different sets of units, we've got to make them the same. So that's our first step. We always go to the smallest unit of measurement, i.e. in this example the centimetres. So we've got to convert these metres into centimetres. So what is 1.2 metres as centimetres? Well, there are 100 centimetres in a metre, so it's 100 point something, so 0.2 is 20. So for this is 120 centimetres. 0.6, it's not quite 100 centimetres, so therefore it is 60 centimetres, and the height is now 80 centimetres. So now we've got 2 sets of numbers in the same unit of measurement. Now try to think of this laterally. What I mean by that is, if you can imagine a room of your own that maybe is small, like a bathroom, maybe a cupboard or something, and the boxes are no more than, again, 25 centimetres by 14 by 14. So they're quite small boxes. And you've got to try and think, how many of those will I be able to fit into it? So there are 3 steps. Firstly, how many along the length, how many on the width, and then how many can you stack on top of each other for the height? And that'll help you visualize this question and get the right answer. So the first step we do is do 120 divided by 14, because that'll tell us how many along the length that it is. So what people usually do is we'll do 14, and if we multiplied, I don't know, let's take 6 as an example. So 6 times 4 is 24, 6 is 1, 2 is 8. So we're quite some way off. So we know it's a little bit more than 6. If we take 9 fours is 36, and 3, 9 times 1 plus 3 is 20. So 120 we've gone over. So now I know it's going to be 1 less. And the reason for that is if we subtract 14 off it, it then gives me 112. You can't do something point. In this example, 8 points something is how many whole boxes. So now we know that I can fit 8 boxes along the length. So now we're going to take the same approach, but this time we're going to do the width. How many of those 14s can I get into 60? Well, if I look at this quite quickly, I can think 14 times the 4. I'm pretty sure that's going to be the right answer. 4 fours are 16 and 1 is 5. I mean 56. Yeah, I was pretty certain on that one. So I now know I can fit 8 along the width and 4 lengths of that. So you've got 8, so 8, 8 and 8 and 8. How high can they go now? Same approach. Okay, so how many 25s into 80? Well, we should be able to work this out quite quickly. So 25, 50, 75 means there's 3 lots. So we've got 8 along the length, 4 along the width, and we can go 3 high. So now we've got those 3 sets of numbers. What do we do with them? Well, quite simply, it'd be 8 times 4 times 3. So 8 fours are 32 times a 3 means 96. And the amount of boxes we can fit in the cupboard is actually 96. I hope that makes sense. Let's go on to the next question. Okay, how did you get on? Well, here we are at question 5, and we're looking at the concept of probability. Probability means it's the chances of something happening. So let's take a very simple concept. If we take a coin, what is the probability when you flick a coin there will be heads? And the answer will be 1 in 2, because there's only 2 options here. It's either heads or a tail. Don't say it'll land on its side. Okay, we're going to catch it. So it's 1 in 2. Okay. If we take the same coin and flick it again, what is the chances of now being a heads again? It is also 1 in 2. Okay, because it's an inanimate object, has no feelings, no thoughts, it just do flick and that. So what is the chances of it being heads and heads? Well, all we do is we multiply those 2 together. It's 1 in 4. Chance of being heads and then heads. So that's just a very simple way of explaining what probability will be. So that's it as a fraction. The question here, and I've simplified this down a little bit, what is the probability of you being one of the drivers that gets the overtime? And if we look at this question, we know there are 5 drivers, which you are one of those, and it's a quarter chance that you'll get any overtime any given week. So if we take that bit of information, and what they want is, the answer is as a percentage and as a fraction. So let's go through. So if you are one of the 5 drivers, and there's 1 in 4 chance of you getting the overtime, going back to like our heads and heads, we do a multiplication of both numbers, and therefore multiplying fractions, we do the tops, 1 times 1 is 1, and then the bottom, 5 times 4 is 20. So the chances as a fraction of you getting the overtime is 1 over 20. So that would be one of our answers. Now, how do we convert that into a percentage? With any fraction, to put it into a percentage, this is the route I take. We all know that percentages are marked out of 100. So the way I approach this is this. I take the bottom number, or the denominator of the fraction, divide it into 100. So how many times does 20 fit into 100? We all know it is 5. I take that 5 and multiply it by the top number. 5 times 1 is 5. So in this question alone, what is the chances from a fraction of 1 in 20 as a percentage? It would be 5%. Now, if that 1, for whatever reason, had been a 3, it's the same approach. 20s into 100 goes 5, 5 multiplied by the 3. That would therefore give us a new total of 15%. And just give you one further example. If the denominator on this occasion was a 10, how many times does 10 fit into 100? It goes in 10 times, and then 10 multiplied by the 3, we have a new total of 30%. So 3/10 is equivalent to 30%. Hope you got that right. Okay, let's move on to the last question. Okay, we've come to the final question in this mock paper. Question number 6. It's talking about you being a delivery driver. So you have to do 2 deliveries. You leave the depot at 8 AM. You're travelling 55 miles to the first drop-off. Then from drop-off 1, you go to drop-off 2, which is 110 miles. And then from that drop-off, that final drop-off, back to the depot, which is another 135 miles. The question is, if you leave at 8 AM from the depot, what time will you return? Well, there are 2 other factors we need to bring in. The first one is we're driving at an average speed of 50 miles an hour, and it takes us 30 minutes when we get to each drop-off to unload our van. Okay, so how would I approach this? Well, the first thing is, I know there are 2 drop-offs, and each one takes 30 minutes, so I know that is going to take me 1 hour. So I need to add that on a little bit later, but we'll bank that for now. Let's go back to how long is it actually going to take me to drive to all of these different points. So what I need to remember is there is a formula to work this out, and I've put the triangle on the screen, very similar to Ohm's law here. But so what we've got at the top, we have the distance, and then underneath it we have speed and time. So quite in essence, if we're trying to calculate the distance of somewhere, we multiply the speed by the time. If we're trying to work out the speed, we take the distance divided by the speed. Now, however, we want to work out how long it takes us. So we're doing distance, which is 55 miles. We're travelling at an average speed of 50 miles an hour, and that will calculate the time. So we take 55 divided by 50. Now, I already know, with my mathematical mind, that equals 1.1. Okay, so now we've got 1.1 of an hour. Now, what you need to be aware of is this. 0.1 of an hour is not 10 minutes. There are 60 minutes in an hour. Okay, and if it's taken as 0.1, which is a tenth, if we divide that by 10, that means every 0.1 is equal to 6 minutes. It's something you need to be very much aware of because it can catch us out. Alright, so the first drop off will take us 1 hour and 6 minutes. If we take the next one, we take 110 divided by the same amount of speed, because we're travelling at an average speed of 50 miles an hour, that gives us 2.2. And the final one is 135, also divided by that 50, which gives us then a total of 2.7. So it would be 1 hour and 6 minutes, 2 hours and 12, and 7 times 6 is 40, 2 hours 42 minutes. However, in this example, 1, 3, 10, nice and evenly round up. So we haven't got to worry about how many minutes it's taken us on this occasion. Okay, 1 over, 2, 4, 5 and 1 is 6. So it takes us 6 hours for the driving, 1 hour for the drop-off, gives us a total of 7 hours. If we add the 7 hours onto our 8 AM, so 8 at 7 is 15. So that the answer you would give would either be 3 PM. Bear in mind, if you're not going to use a 24-hour clock, you've got to indicate PM or AM. Or, if you are using the 24-hour clock, it would be 1500 hours. So that's how we get to that point and answer the question. But for the more astute people out there, you would have seen another easier way of doing this. Because the speed that we're travelling at is constant, okay? It hasn't differed from the depot to 1, from 1 to 2 and 2 back to the depot. Because it's been an average speed of 50 throughout, what we could do is add all the totals up, which comes to 300, and then divide that by the 50, which would give us the same 6 hours. The first method I show you is the right method should you be having different average speeds for whatever reason the question may give you. But if you're finding that the average speed is constant throughout, just add all the distances up, divide by the average speed, would give us the time. Well, hopefully you got that question right. Okay, there was 3 marks available, and I think there are 3 good, easy marks to gain there. Let's wrap up. That concludes going through that mock non-calculator paper with you. I'm hoping from each of those questions you can see how you can maximise the amount of marks you can earn through each question. A lot of the calculations you may have thought to yourself, well, that's quite simple, I can do that in my head. But you've got to showcase on the paper, both the mock, but really importantly on the real test paper, how you got to that answer, even if it's some of the most basic functions that you were aware of. It just shows the invigilator that you have a lot of understanding about how you got there. I've seen it in the past where some people have made some most simple mistakes and they said to me, Tony, do you know what, I knew the question, I knew what to do, I just made, I rushed it, whether it was with the calculator or they've just misread something and they've gone racing ahead. So hopefully today gives you a bit of an insight how to get those maximum marks. The final thing I want you to do now is be honest with yourself, work out how many you got correct, how many marks you would have gained from it all, and then work out what percentage that equates to. Now, I always try to get everybody to aim towards 65%. That gives us a nice good buffer on our pass mark when it comes to the real test paper. So if you're unfamiliar how to work out what you scored, okay, what we do is we take the maximum marks for that paper is 17. If we scored, let's say for example, 11, okay, we multiply the 11 by 100 because all percentages are worked out of 100, okay, and then finally divide that total, which is 1,100 divided by 17, and that will then give us our percentage. I hope this has helped, and I look forward to doing some more videos with you soon. Thank you.